Welcome, guys. We are into the 9th module of NBMS initiative of AI in health education. We have two eminent personalities to take us through this module. One is Mr. Ghosh, other is Mr. Ravi Bhardwaj Annamraju. So we don't require a special introduction to Ghosh, but to refresh your memory, he is a guy who moderated this session in the module 2. He is a AI technology professional associated with large MNCs and a faculty member at the NBMS AI Healthcare curriculum, one among the 30 faculties. He is active and keen in community education regarding how we use machine learning in real life. He contributes to bridging the core concepts of data science and AI with the real-world clinical applications, which is the essential need for us today. Just FYI, he is a couple of times Guinness World Record and the impartial judge for one of the largest hackathons, which won the Guinness World Record as well. To moderate this session, we have Mr. Ravi Bhardwaj, who is a senior leader at GE HealthCare. He drives the innovation at the intersection of AI, digital health, and medical imaging. He plays a key role in advancing the data-driven healthcare solutions that improve the diagnostic precision and clinical workflow globally. So, Neil, just want to understand from you how you are going to teach us regarding the deep learning in medicine, specifically to images, text, and signals.
Thank you, Dr. Suresh. Thank you so much for the kind introduction. I want to thank you, NBMS, for this opportunity. It's a privilege to be able to contribute something to a community that goes out every day and saves life. It's also incredibly humbling to be part of a curriculum featuring so many inspiring doctors and scientists and personalities like Ravi here. In Module 9, we are going back and pick up where we left last lecture. We'll talk about how machine learn, but now we are going to apply the intuition to medical imaging, to be specific. We'll dive into convolutional neural network and see exactly how AI looks at the images like X-rays, MRI, and CT scans. We'll cover some really fascinating use cases from image segmentation, classification, and restoring images, and even generating synthetic data. We'll also touch upon the recent tech innovation of generative AI and how embeddings are used in medicine. Then we'll switch gear to time series data, looking at how AI learns from the continuous signals like ECG and EEG, and to actually predict event before they happen. As a programmer, engineer, one of the most exciting areas for me is what large language models are doing to text, because code is text. It has completely changed the game, making traditional search algorithm outdated, even in the medical context on the data we have. We'll try to finish up with a hands-on demo so you all can experiment and see these in practical use case in actions. So looking forward to it, quite excited about it.
That's so nice of you, Neil. It's really exciting to understand. Ravi, I think Neil covered probably a 10 days lecture into 10 minutes sort of thing. I know medical imaging itself is very vast. So as the signals prediction, everyone will doubt. It's just like astrology. You go with your hope and then astrologers say it's good, then you doubt. If say bad, then also you doubt sort of thing. So how exactly it is going to work? Because you are in the actual industry where you bridge between the research and the practice. How do you look at it, Ravi?
Thank you, Dr. Suresh. I think this is a great initiative. As I saw, you're powering the next generation clinicians with the next generational tools in terms of intelligence inundated with data. You are fed with a lot of data coming your way, be it imaging, where imaging has exponentially multiplied in terms of number of images, number of methods. Same with even text. People are writing a whole lot of text. You're getting generative information, etc. And same with waveforms. Your Fitbit and all your wearables are producing humongous amount of data. Now, what does a clinician typically do as one of their key activities? They look for patterns. They look for normal, abnormal patterns, right? And looking for patterns in such huge repositories of data is extremely hard, cognitively really challenging, next to impossible. So the tools that Neil is bringing together are the tools that help you to surface patterns, to identify patterns so that you can form your hypothesis. Given a patient's medical history, what's the first thing that comes to a clinician's mind? What's wrong with this patient?
Right.
Where is it wrong? What's wrong? So they're constantly comparing it with what they know as what's right and what's wrong, and they're looking for patterns in the patient's data. Now, a patient's data can have imaging, text, and waveforms. So this topic is extremely relevant in order to help you spot patterns and quickly come to the problem so that you can answer the problem, you can solve the problem. Today, we spend a lot of time trying to find the problem. You all know the answers, you're looking for the question, right? So I'm also really looking for. Thank you.
That's so nice, Ravi. And Neil, we are eagerly looking to welcome you for the actual session between 4 p.m. to 5 p.m. this 25th of March. And just to say that, we are medical doctors, and the data points which we are going to see and then speak are all synthetic. I hope both of you will agree on those points, right?
Absolutely.
Right. Thank you very much. Have a good day.